Hello, Twitch, and welcome back. We are here at the expo floor here at the AWS New York City Summit. I'm Nick Walsh. I'm a technical evangelist here at AWS. We've got a really awesome session lined up for you here. I've also got my co-host down at the end, Kunal. Why don't you tell the folks what you do here?
Hey everyone, I'm Kunal Batra. I'm a senior technical evangelist here at AWS.
Awesome, and the guest of honor here for our session, Ran Ribenzaft. He is the CTO of Epsagon.
Yeah.
Epsagon is an amazing company that helps you monitor and have observability into your serverless applications.
Exactly.
Yeah, so I don't want to steal your thunder. Why don't you tell us a little bit about Epsagon, maybe the journey, or like who really loves Epsagon, and tell us a little bit about your product.
So this is mainly products targeting developers. Developers nowadays moving to serverless and managed resources, finding themselves hard to understand what's going on in production. Lots and lots of resources, functions, managed resources, and it's starting to be a chaos in understanding what's going on, both in monitoring, making sure the application is working properly, but also when something bad happens, diving into logs and understanding what happened in a distributed scenario is super complex. So we give the ability both to do monitoring and troubleshooting under the same suite.
Awesome. So these are some of the challenges that Epsagon helps to solve. So.
Yeah.
What does this look like? You know, like obviously applications exist in a very distributed fashion. You have everything from the point where the data comes in to where it's being stored to how it's being queried. What is Epsagon's approach to solving this problem? What does the product offering look like?
Our main approach is to have an SDK that integrates to your code. So you don't need to install any agents whatsoever because it doesn't fit the new future of everything managed for you. Once it's integrated to the code, you can easily gain insights to what your code is doing on runtime, including calling AWS SDK resources, calling third-party APIs, calling managed resources, databases, message queues, storage, and so on. While when you get this, you get visualized, and we'll soon show that, you get visualized depiction of everything that happened. So it's really easy to understand where are you wasting your time, what are your bottlenecks. If something bad happens and you want to filter out just a specific user ID or a customer ID, it's very easy to pinpoint that. So developers can iterate much faster. If we're talking about the development velocity in serverless, this gives you the assurance to run faster and gain the confidence on cloud and modern applications.
So before we get into more of the troubleshooting and monitoring, we're talking about serverless, we're talking about microservices. Can you talk a little bit more about that paradigm of development and how it's different from maybe classical coding practices?
That's a great question. So if we'll take a look at what happened before, like with monolithic applications or lift and shifts to a server, you had a single monolith where everything happened in this monolith. Now, when you're breaking it down to lots of services, you're getting a distributed system, which talks to one resource to another, streaming messages, asynchronous events, calling to one another in HTTP or socket-based events. And then you end up with hundreds of resources running in production. Some of them are container-based, some of them are Lambda-based, some of them are just managed resources like API Gateway and SNS and SQS and Athena, and on top of that you can add tons of other services, and you're having running messages from one point to another. This is a totally different paradigm, both in the way you develop and in the way you monitor and making sure everything is working properly. So you need to have the right tool that will tell you the story of everything that happens, rather than just a single dump of log that everything happens in there, because you won't see that. You'll need to correlate between logs, you'll need to correlate between events, you need to search a needle in a haystack of tons of requests, which we just talked about. It's a different mindset, it's a different development approach, it's a different way of doing things modernly.
So with this comes, I guess, different challenges, right?
Right.
And can you talk a little bit more about the challenges? You mentioned complexity because now with the serverless application, it breaks down into lots of little Lambda functions, but talk a little bit more about that.
So let me talk first about the great advantages of serverless. First of all, you're having managed resources. I don't need to manage my own message queue, my own database. It's totally operated by AWS, which is great. But now when something bad happens, I have no longer access to the host. I mean, I can't log into the S3 bucket and see what went wrong. Or I don't also need to know about CPU or memory metrics because I don't really care for the SNS or SQS, how much memory is being consumed. It's even obfuscated for me. Same applies for Lambda, and there are other challenges that are coming in terms of monitoring and making sure everything is working properly. That, first of all, it's different kind of metrics. The metrics are more application level rather than the infrastructure level. I don't care about like CPU idle time in Lambda. I don't care about memory consumption. I care about more how long my code is running. which resources are performing slow or not, and whether my customer is getting the best experience that I can have him using these serverless resources. And also when troubleshooting, so a different mindset is about the logs. Usually you can find many companies today put all their logs in some unified place. It can be Elastic, managed Elastic by AWS also. But when you're having hundreds of resources, putting all their logs, and you've got a massive amount of scales, millions of requests per day or hundreds of millions per request per day, searching logs, it's becoming a really difficult problem to solve.
Yeah.
Yeah, so I think it becomes like abundantly clear, right? There are companies where this is a burning need, right? They're in too deep. They have this huge distributed architecture that they've scaled out, and they feel the pain point of not being able to look at the data and have the observability they want, either in the event of an incident or just trying to understand their traffic.
Right.
So that's the obvious use case here, right? You're in too deep, you need an observability solution. Could you walk us through sort of like the tipping point where a customer might start considering to use this, where going from just developing their first serverless application or starting to scale something out to where the ideal customer entering in Epsagon's world would be?
So that's a great one as well. So when you start with serverless, it's pretty easy. You set up your own first Lambda function. It's a matter of, let's say, 5 minutes when you're getting deployed, and all running smoothly. But when you're going into production and you have more than a single function, you have, let's say, tens of them or hundreds of them, and you're starting to figure out yourself, am I looking too much in logs and they don't tell me anything because it got no context? I can't see what my Lambda is doing. I'm getting timeouts. I'm getting out of memories in my Lambda function. Things that you need to take into consideration when you're hitting this tip point. You need to make sure you've got the right solution. And this is exactly where Epsagon kicks in. And actually, I would love to show.
Yeah, super excited. We can talk about it all day, but I know you are the person to show us the demo, so let's take a look at it.
Perfect. So first thing we see is just making like who's versus who in the zoo. You'll be able to see all of your functions in a nice table from multiple AWS accounts, any region, any runtime. You can also see the triggers. I know there's a big chaos of, wait, is this function being triggered by a Kinesis or an SNS? Did we change it or not? So just keeping track of what's going on in terms of functions is great. Now, on the right-hand side, you'll be able to see performance metrics, invocations and errors, which are pretty basic, but also timeouts and out of memories, which these are crucial. If you don't know if your function is running out of time, you're like almost blind to production. You can't know if user is getting the right experience or not. And even cost. At some point, I love the fact that it's scaling out of the box, but with great scaling comes great responsibility. So you need to make sure you're not overscaling and you know what's the impact on your cost as well. So when you want to troubleshoot a specific function, let's say I'm sorting by the errors and I've got this post-analysis function where I want to troubleshoot this kind of error. So I'll be able to click on that function and I'll be able to see each and every invocation that happened to this function. First of all, I'll be able to see some more metrics like invocations and errors, memory usage, duration statistics, which, by the way, presented in percentiles, which in this exact example, you can see that usually it runs pretty fast. But I've got a percent of request that is not very good. It doesn't meet my SLA, and this is the one I need to focus on. Then you can see below that the list of invocations. Like every invocation that will happen to your function will be listed here. And the magical thing is that you can filter out anything. For example, show me only failed invocations or timeout invocations. Show me only invocations that took more than a second because that's not good and I want to know what's going on there. Or a specific time frame or even a specific request. Now you talked about the use case. One of the strongest use cases that we found out is that once you're having a problem, the next step that you do is going out to the logs. And sometimes when you're having tons of logs in CloudWatch, it's okay, but it's hard to navigate through log streams and log groups. So instead of what we just built on top of CloudWatch logs, the ability to get each and every log. So just clicking the log, and we pull out the right log from CloudWatch to you. So you don't need to manually figure out or try to filter, or it's there for you. Now this is the basic thing that Epsagon offers. Our core competency is traces or distributed traces. And this is the magical part where, as you can see, we got tons of errors here, a zero division error from Python. We extracted from the traceback. And when you want to troubleshoot a specific event or a specific story in your system, you can click on that and actually see a full trace of everything that happened from one end to another, starting from the API gateway. So I can click on the API gateway and see which headers was corresponding to that specific request. I can see which Lambda did this API gateway triggered and also see the logs of this Lambda. It's also traced across asynchronous events. If I'm putting a message to an SNS in this example, and this is the message, I can see which Lambda is being triggered afterwards and see all the payloads for this Lambda as well. Even if I'm putting an object or an item to a DynamoDB, I can see which item I put on this DynamoDB. Also, not only AWS SDK requests are traced over here, also HTTP requests, like, for example, Auth0, Twilio, also databases like MySQL, Postgres, Redis, and Kafka, and all these resources are traced for you. So visualizing it this way, it's much more easier to troubleshoot and understand. Yeah. In this example, by the way, we've got some error with Auth0. Sorry, Auth0 guys. A 401 on the status code, but now the developer will come and will say, okay, I need to print out the response body to understand what did I got 401. Yeah. And instead of that, Epsagon already collects it for you. So you know that we got expired JWT. I know what to do next. I know how to fix my software.
Yeah. So sorry.
Sorry. Yeah, I was just going to say. So instead of thinking about a distributed system as just tons of logs, or going directly to the service to try and see what the response body was there, you can think of your application in the way that we are, or you can see it in the way that we already think about it, which is a end-to-end application. And even if though they're coupled by the handoffs that occur, we want to be able to visualize that. And so problem identification is critical before you can do remediation, right? And so you don't want to have to go and start at the root and go all the way down. You can quickly click through here and see exactly not only that there was the status code that threw the error, but also what the response was, so you can easily troubleshoot downstream and know where you need to perform remediation. Yeah, I think that this picture really says a lot about a trace worth 1,000 logs, like a picture worth 1,000 words. So it really makes it much more easier to navigate through. And also, we offer the ability to watch it on a timeline view, so you'll know where you spend your time. In a Lambda, I mean...
I was about to say.
Yeah, you've got several runtimes of a Lambda, but what's going on inside this Lambda? How much time do I spend calling Auth0, or putting a message to an SNS, or calling another resource, or a DynamoDB? Everything is visualized here, and I know if I wanted to optimize my application or my Lambda function, it's really easy. I know where I should start and what's taking so long. I mean, even if I just had a single Lambda function, I feel like having this this observability tool is super interesting, not just from a performance perspective with knowing how long things are taking, but a cost perspective, right? So in the serverless paradigm, things are priced at a per unit of time basis. So if I'm trying to figure out, okay, well, am I performing a transformation of data that's computationally intensive or not super efficient? You'd be able to see that from that function or the API calls that you're making, and you'd be able to discern where you can start making improvements, even if there's not an explicit error. Right. See where you're spending your time, which is where you're spending your money in the serverless world. Yeah, and sometimes another great use case is to just filter out for a specific event. For example, a customer says to you, something didn't work out for me. Searching it for the logs, if you haven't logged it manually, you wouldn't know about it. But all of a sudden, with Epsagon, you can just search in traces anything. You can ask the most complex queries or the most simple ones. For example, show me only events that included the word Netflix for some reason. I want to troubleshoot that because I know there is a problem with this specific blog post. So I can see any event, in this example, API Gateway or SNS, I can click through any kind of this event and see the full trace out of here. So this one is actually pretty similar because it's the same path, but on the request body, I can see that the word Netflix event included, and this is the full post about everything that happened over here. So it's really easy to look for, let's say, a customer ID or a user ID or some headers or some metadata that you know that you're looking for instead of looking for logs whatsoever.
So find bottlenecks, optimize latency, find errors. How do we get started? How do AWS users get started with this?
That's a great question. We do two things to integrate with current customers. The first one is deploying a CloudFormation stack. This CloudFormation stack allows us to list functions, to list also ECS clusters and Fargate clusters, and just visualize or putting everything into table of everything that we saw before that. This is the first step, just exploring the account and letting the user know what's going on. The second step is to deploy the tracing library, the Epsagon tracing library, which is open source and on GitHub as well, where you just, if it's a Node or a Python, you're installing it with NPM or pip or Maven and so on, and you're putting it into your code, and from that on, you don't need to change anything. You don't need to manually annotate anything that you do in the code. You don't need to tell Epsagon whether you're having this kind of event or other kind of event, whether you're putting an item in a DynamoDB or getting an object from S3. Epsagon collects it for you and visualize it on this part of the traces.
Perfect. Does it take advantage of other items like Lambda layers as well, where if I have multiple functions, I don't have to keep calling it in every single one?
Actually, yeah. We got a great technique using, we call it auto-instrumentation. So putting the library, we call it instrumentation, But then once layers was being introduced, we had this feature where a customer can just click on a function on the function screen and say, I want this to get instrumented. I don't want to change configurations. I don't want to change anything. And using the layers, we just add the Epsagon layers to it and update some parameters for the function. And from that point on, the function is getting traced. No need to change anything. It's almost like a magic. Some customers don't know what's happening, so they try to trace what requests are being made, so something changed, but they don't know what.
So, like getting down to nuts and bolts here, it's a library. They can just import it, right?
Yeah.
And so, like in Python, for example, is this a decorator they put on top of their function?
Exactly.
Yeah. So I was going to ask, do developers need to change their code? Because that's something that people they're not happy with. Obviously, it takes time.
Right.
You have to get onboarded. The idea here is, and correct me if I'm wrong, you can take your existing function, you use a decorator, which is just a specially signed line of code in Python, and I know there are equivalents in other languages probably, where you can have it inherit this behavior for tracing.
Yeah.
And so again, you don't need to write Epsagon-specific code inside of your function. You just put this little decorator right on top of your instantiation, and you're good to go.
Yeah, the main thing that we offer is automating everything. So by automating developers, or the developer experience is almost seamless. You don't need, developer doesn't need to add anything in their code or annotate or segmentize or label anything. Epsagon automatically captures everything, and it keeps running smoothly as the same as it is.
So as developers, we care about performance as well, and this is happening in the background. Does this affect the performance of our applications, or our Lambda functions, or microservices?
It's definitely affects, but a very minimal affection. So the way we make it to be so much not impactful to the customer, to the user's code, we deploy the collector in each and every region. So it honestly takes like basically 2 or 3 milliseconds to send out the data. So at 2 or 3 milliseconds impact and barely nothing on CPU, like less than 1% of CPU, it's very negligible. And I think when you're in production and you want to monitor a problem, 2 or 3 milliseconds worth it, of course, just to reduce the mean time to response.
Yeah, I was actually just about to ask because Billet75 in chat wanted to know what the overhead or the change to performance is. So again, 2 to 3 milliseconds, and top around 1% on a Lambda, right?
Yeah, thanks to Amazon, thanks to AWS. We also run on AWS, so our collector deploys in all 17 or 18 regions of AWS, so that makes like a super fast connection, and we optimize it on our backend to be super, super fast.
Nice.
So I was going to ask, this sounds amazing. I can think of ways I would use this. I know we spoke about, if you're in too deep already, what are some of the most exciting ways customers are using it that you've seen? Or like, are there particular customers that have seen huge impacts from being able to leverage Epsagon?
Actually, I got two great examples. One of them is an insurance company in the States. They moved all their workload from AS400 COBOL all the way to serverless Lambda. It's like a leap of faith, like moving that far. And using Epsagon on the day-to-day development really helped them to grow quickly and iterate much faster, because these are people that haven't handled AWS before that. It's something that they need to know, and this visualization really helps them on a day-to-day basis. Another use case, it's just for development. I mean, it obviously helps for production, but in serverless, we really talking a lot about development velocity, like the ability to iterate faster, ship code faster, and even if it has problems, like let's fix it quickly. So with Epsagon as part of your tools in the arsenal, you can easily deploy, see the trace, see whether it was behaving properly to what you wanted to do, and then move on to the next text.
Yeah, I mean, that's a really great point, right? Because a lot of tools in this space sometimes focus on the identification of problems and then remediation.
Yeah.
But feature velocity for getting better insight into your actual application, its behavior, clearly has huge performance benefits here.
It's amazing. Customers that we see growing from 100 functions to thousands of functions in just a matter of like few months. It's amazing.
And I have one more follow-up question from the chat. This is Robert Tables. He'd like to know if there are many people that are new to AWS using their tool. So people who are beginning with serverless or beginning with cloud computing, what's their journey look like with Epsagon?
So it's pretty much the same. Even if you're new or you're an existing customer, the onboarding is pretty simple. You set up the CloudFormation, you set up the code. You can see everything that happens from the beginning, even if it's just development play. We got lots of customers that are doing development play because they prefer to look at Epsagon rather than reading logs or trying to debug manually what's going on. So even for newcomers or existing customers, the experience is exactly the same.
Awesome. Well, I think we're running up against time, but Ran, thank you. This was
Oh.
an awesome demo. I know lots of people in chat are excited. I'm excited to
Thank
just
you
use
very
this when
much.
I'm writing lambdas and serverless functions. But I think
Oh, so go ahead.
Go
I'll say
ahead.
last 10 seconds. Where can our users go to find out more?
So one of them is the GitHub repo, github.com/Epsagon. We got lots of great open source utilities out there for benchmarking and cost analysis and monitoring basic stuff. Also, we got some great blog posts on the epsagon.com/blog. Feel free, there are lots of technical posts about how to work with Lambda and other managed resources that AWS offers. Thank you.
Right.
awesome. Well, thanks again for tuning in, and stay tuned. We've got lots more exciting sessions here live from the New York City Summit floor at twitch.tv/AWS. See you soon.